control system for the University of Puerto Rico Mayagüez by Héctor Franchi, Keishla Ortiz, and Juan Bermúdez.
Hello everyone, my name is Juan Pablo. My team members is Héctor, Keishla, and we are the group HKJ, and we are presenting Sisca. A short study performed on the largest parking zone on the campus, the one behind the library, shows that the 28% of parked cars in that zones is around 28%. So that situation and the situation that during the past years that the number of available officers has been diminishing during the past years leads to a parking access problem at the UPRN. So that's the reason that we are presenting Sisca, a centralized parking system that will work with RFID technologies for detecting incoming tax places on the vehicle's windshields. So, regarding to our objectives, well, we can say that our objectives are completed successfully in 100%. So the objective of implement and test a complete centralized fully integrated system have been done. So now I leave to Héctor that is going to talk about and give to you a better description of the system.
Thank you, Juan Pablo. So here we can see the final system architecture. It remains almost the same after the design phase has passed. Here we have the SAD, which is the actual physical device that will be located at the entrance and exit of every parking, and will control the access to it. And those are its hardware components. We have the CAS, which is the software of the system for administering the devices, permissions, the authorizations, and all of that. And the server, which contains the database of the system and provides for two-way communication between both modules. So from the design phase, only these changes have been performed. We have chosen the Team Magic Micro LT RFID reader over the M6E, which we have chosen first, because it provided mostly the same features that we required and for a cheaper price. And since we want to make the product cost efficient, so we decided to choose that over that. Other than that, no other major changes except for server software that was made in Java rather than Node.js. We have provided now an authentication system for each device using the long algorithm. More about that a little bit later on. And communication now uses sockets rather than HTTP requests. Also, we have added to the display features to provide more feedback to the user. So the final system specifications stay mostly the same too. We have a maximum tag detection distance of 20 feet. We have tag write times of 1 second. The antenna is now placed at a 7 feet height. And the maximum time from reading a tag to opening a barrier gate is 2 seconds, down from 5 seconds that previously was. The system synchronization time is now 10 seconds, down from 15. And due to a mention by Professor Beauchamp, who said that maybe the device could be apart from the antenna, we recommend that the maximum cable length for connecting the antenna to the device is 15 feet long. So now we're going to show you a demo of the system running of our prototype. Here is the initial configuration wizard, where you can place the company name and the product key, because this software will be sold on license, and it has to configure the IP address of the server where all communication will take place. Also, it allows you to create an account for administrators at first time, and that's what it's doing right now. Right now, we will try to log into the system. The login will be, if the password is incorrect, the system will not allow it to enter, as you can see. And so now that we correct the password, we will see the home screen of the prototype. Here is that. we can see that the user account was created in the wizard and is present there with this information. We will now pass to create an authorization type, which is the way we classify vehicles, let's say like green zone, white zone, orange zone, all of that. There is the authorization type created. So now we're going to configure a SAT. Each SAT device have a unique ID, which is like the credit card number. So they are randomly generated, but have to follow some specific rules and for being a valid ID. And the reason for that is to avoid possible attacks from outsiders that try to generate a 16-digit random number and try to enter the system without authorization. So now we're going to configure a parking. And a parking, we can add, we can say which days it will operate, which time it will operate, which devices it will allow, and which authorizations it will allow. We will now see how to configure a permission. For the permission part, we have followed the same format that you can see on the UPRM website when you try to fill in for a parking permit. You will see that the fields are almost all the same, except that it includes some fields for the tag information that the vehicle will have. The tag that the vehicle will have, it has to have an ID and its authorization type and other things. But otherwise, the information is the same. You need to fill the vehicle information, the user information, and all of that. Now we will see the demo, the editing a parking functionality. We're going to edit this to remove this authorization type and add another. Over said change it. So as you can see, you can change and add authorizations and also the devices that the parking will have. And now we will see a live demonstration of the system. That is the SAT device, or at least our prototype. And we will test this with a parking that has 2 lots of capacity. We will pass a tag, and you will see that an LED will flash to feedback the user that it has been read. And the capacity has gone 1 less, because now there is less, 1 parking less. And we pass another tag, and now the parking is full. And it will detect it and turn on the LED, and it will let it on to signal the users that the parking is full. So now we will pass a tag that is not authorized, and you will see that it will flash many times, telling the users that it is not authorized, and the LED will stay on because the parking is full. Also from the live system, we can open or close the entry gates or the exit gates, and we can also open all gates of the system in case of an emergency. So now I leave you with Keisha to continue with the methodology of the system.
Methodology. On technical managerial approach, we use the stream programming and the V model. Both techniques are used in software development. The V model suits this project due to the constant needs of testing and validation before moving forward in development. And from stream programming, we adopt the pair programming practice. For testing and quality control, we perform procedures and tools like the use of flowcharts, checklists, status meeting, and the PDCA procedure, that means plan, do, check, act, that ensure a plan before commit and implementation. In the budget, this table summarizes the total expenditure on the allocated budget. The workforce salary was calculated based on the average salary of 3 computer engineers. On the hardware components, the most expensive was the Thin Magic development kit that cost around $700. The other components are the Raspberry Pi, some resistors, capacitors, wires, and the LED. We can notice a saving of around $40. Some major project impacts are, for example, the reallocation of security officers to do more important tasks, increasing security and traffic control in parking lots, provide a robust security mechanisms against possible abuse, and decreasing the cost of purchase new parking permit because our tax can be written with new information every year.
So time is over, but if I don't know if they will allow us to continue the presentation. Otherwise, any question? Yes.
Okay, you mentioned that in case of emergencies, all the gates can open, but in case of a specific emergency, for example, a student falls down in Maria Blanca, and then the ambulance has to get in, how is the control used so an unauthorized vehicle without a parking permit is able to go in under those cases?
In that case, that will happen on a specific parking lot. So, so the live system you can open it automatically.
Okay, a person like, let's say, the police, campus police will open the.
Yeah, and also that was part of future work that we have planned. We wanted to make a mobile application that could also open gates and close gates, but specifically only for the officers of the university. Any other question? Thank you very much.